All right, here's a couple of questions that deal with radian measure and measuring rotation in radians. First one says mark approximately location where the given numbers on the end of the circle. So all the numbers that they give you, all of these, are all radians, not degrees. Like you see 229 here, you think, well, it's degrees, but if there's not a degree symbol like that, then this means radians. Okay, so the first one's 5.9. Now, if you want, you can take 5.9 and multiply it by 180 degrees over pi rads. And 5.9 is rads, so the rads cancel. So you can multiply and divide that and come up with a degree measure. And that maybe helps you determine where in the quadrant that happens. One thing I like to do is I know that one whole way around a circle is 360 degrees, but I know that's the same as 2 pi. And if you go 2 times pi on a calculator, it gives us 6.28. So it gives you a bit of a reference as to how far you have to go. So if they say 5.9, I know 6.28 is here, so 5.9 has just got to be just shy of that. So I'm picking probably this one. 5.5 has got to be in the same general area, maybe this one. 37, ooh, no. 37, I know 6.28 is once, so that would be what, 12.56, is that twice? And I guess I'd have to keep going. An easy way to figure that out, though, is just go 37 divided by 6.28, and that'll tell you how many rotate or revolutions that you've made to go around. And then when you divide that, whatever comes out in the decimal portion, that's a portion of another rotation. So if it comes out to 0.8 of a rotation, then you know that's pretty well almost all the way around. If it comes out to like 0.2, then that's probably just somewhere in the start here. If you take that 0.2 and multiply it, say, by 360 degrees, that'd tell you, I think that comes out to like 7 degrees, 7.2 degrees or something. That'll give you a degree measure that you can sort of eyeball up to see how far, or yeah, how far it is rotated. All right, hopefully that helps. Number 2. Number 3, they say convert to radians, so negative 212.6 degrees, and I'm multiplying that by degrees as what I want to get rid of. So I'll put the 180 degrees on the bottom, and that's the same as pi radians. So the degrees cancel out. So if it were me and I wanted to figure out the radians, oh, hold it. The question says put in a simplified fraction, ooh, and exact terms in terms of pi. Well, if they have a decimal to start with, I really don't agree with the question. If they give you a decimal to start with, that's not an exact answer right off the bat. And so doing it in exact terms is a little awkward. I guess what you could do is go 212.6 over 180. We have to leave the pi in there, they say. And then maybe you can multiply top and bottom by 10. So that would be that, and this would be 1800 on the bottom, pi with a negative. And then maybe simplify that. So divide 2 into top and bottom. 900 on the bottom. On the top, you'd get 1063 or something like that. You could do that. But like I said, if they give you a decimal to start with, you can't really give it an exact answer, because any decimal is an approximation. What I would have done is just gone this times pi divided by 180 and come up with a decimal answer. But this is sort of where they're heading there. All right, question 8, worded problems. In a circle with 104 radius, circle radius 104 inches, how long is an arc associated with an angle of 5.6 radians? So 5.6 radians, maybe I should have put that line right there. 5.6 radians is somewhere over here. So they want to know how far it is to go from there all the way around. So our formula is an angle is equal to the distance divided by the radius. So looks like we're trying to find the distance around. So S is going to be equal to theta times by R. The angle is 5.6 radians times by the radius, 104 inches. So if you multiply those two, that should come out to what that arc is. Similar kind of question. Oh, they're giving me a speed here. And this is radians per second, so this is an angular speed. They give me a diameter. Oh, trouble. I always have to convert that to radius. So if the diameter is 16, radius has to be 8 centimeters. Then they say, what's the linear speed of a point on its rim? Okay, I can do that. Velocity is equal to the radius times by the angular speed. Radius is 8 centimeters. Angular speed is 9 rads per second. I think that's good. So 8 times 9, 72 centimeters per second. Oh, they want in centimeters per minute. So I can take that 72 centimeters per second, use dimensional analysis to convert the seconds into minutes. So I know 60 seconds is equal to 1 minute. Notice I put the second on the top here so I could cancel them. So 72 times 60, I don't know, 12, 1, 4, 3, 20 centimeters per minute. All right, last question. Rider bike race, average speed 39.513, wheel diameter, radius is half of that, 33 centimeters. What's his angular speed? So they're going for this. And they tell me the velocity. So again, I'm using this formula, but I'm looking for this. So it would be angular speed is equal to velocity divided by the radius. So the velocity, 39.513 kilometers per hour, and the radius is 33 centimeters. Oh, trouble right here. I have to get the same unit there. So let's convert one to the other. Why don't we convert the centimeters into kilometers? It doesn't matter. Anyway, I know that there are 100,000 centimeters in 1 kilometer. That's that King Henry, what's that whole thing? Kilo, hecto, deci, is that right? Centi, milli, 2, 3, 4, 5, 7. I think that's right. So to get from kilo to centimeter, it's 1, 2, 3, 5. Yeah, so 5. So 100,000 centimeters, 1 kilometer. So that's centimeters would cancel. The kilometers would cancel. Perfect. So my angular speed is whatever this times this divided by 33 is. And that will be in radians per hour. Uh-oh. They want the answer to be in revolutions per hour. Okay, well, if I talk about revolutions, so I know that 1 revolution is the same thing as 360 degrees, but in terms of radians, which I need, that's 2 pi radians. So I can take whatever my answer here was, that was in radians per hour, and I can times it by, let's see, I want to get rid of rads, so I'll put this on the bottom. 2 pi rads is the same as 1 revolution. I didn't need the 360 degree thing. So rads cancel, I'll be left with revolutions per hour. So just take what your answer is there, divided by 2 pi, and you're good. Make sure when you divide that, so you put whatever answer divide, make sure you put the 2 pi in brackets. Otherwise, it'll divide by 2 and multiply by pi. So you want to divide it by that whole thing, put it in brackets. Right, hopefully that helps you.